Congruence modulo is an important topic in number theory. Congruence means compatible with or agree with, and modulo means measure. We say A is congruent to B mod n, where A and B are any integers, positive or negative, but n is a fixed positive integer. Now, before going into mathematical definition of congruence modulo, let us try to understand this through an example. Consider here a clock where the 12 hours are marked on this. If somebody uses 24-hour format, then 1 p.m. can be represented as 13, 2 p.m. as 14, 3 p.m. as 15, and so on. As the numbers keep growing on both sides of the number line, they start wrapping around, making a cycle of 12. So this data set 1 to 36 in our case can be classified into 12 disjoint sets. These 12 disjoint sets are memory locations in the computer. So within each set, the elements or the numbers are said to be congruent. 3 is congruent to 15, 15 is congruent to 27, and you can see here the property each number is increasing by 12. So after 27 we can expect 39. Another interesting property is that within the same set, all these numbers when divided by 12 give the remainder as 3. And another property is if you choose any numbers A and B, random numbers within this set, their difference is divisible by 12. For example, 15 and 39 belong to this set and their difference is minus 24, which is divisible by 12. So all these numbers within the set are said to be congruent to each other, where A and B are any random numbers within the set and n is the fixed number 12. Now suppose the data set represents the bank account numbers or insurance policy numbers, and we want to retrieve the record pertaining to a particular policy number, say 11253. Then this number must have been classified in any one of these 12 memory locations. But how to identify this? The technique is the number 11253 is divided by n, where n is 12, and which leaves the remainder as 9. So it means the number 11253 is congruent to 9. So this number belongs to the set 9, and the beauty of this modular arithmetic is the modular function always returns the remainder, and this remainder will always be less than n. So however large the number may be, it will always be scaled down to the smaller number. And this concept is used in the hash function in retrieving the records from the database. Now we are ready to define congruence mathematically. Suppose A and B are any two integers and n is any fixed positive integer greater than 1, then we say A is congruent to B modulo n if and only if n divides A minus B, or A minus B is multiple of n. Then we say A is congruent to B modulo n, and it is written symbolically as A congruent to B mod n. If n doesn't divide A minus B, then we say A is not congruent to B mod n. So here A and B belong to different sets. That is why they are not congruent to each other. In this example, 155 is not congruent to 4 mod 10. A is 155, B is 4, and the fixed number n is 10. Now as per the definition, A minus B is 155 minus 4, which is 151. Certainly 151 is not divisible by 10, hence they are not congruent. But if I change 4 as 5 here, then 155 minus 5 is 150, which is divisible by 10, or 150 is multiple of 10. I can also interpret this in another way. When 155 is divided by 10, it leaves the remainder as 5. In the third example, 25 is congruent to minus 8 mod 11, because 11 divides the difference of 25 and minus 8. 25 minus of minus 8 is 33 and it is divisible by 11. So 25 and minus 8 are congruent. 19 is congruent to 27 mod 4, because 4 divides 19 minus 27, which is minus 12. Or we can say 19 and 27 when divided by 4, both of them give the same remainder 3. Hence they are congruent. If A and B are congruent with respect to modulo n, then the following statements are all equivalent. A minus B is divisible by n, so also B minus A. Or n divides A minus B. Or A minus B is a multiple of n. Or B is the remainder when A is divided by n. A and B leave the same remainder when divided by n. Properties of congruence modulo. Reflexive property. Every integer A is congruent to itself, because A minus A is 0 and 0 is divisible by any integer n. Symmetric property. Whenever A is congruent to B mod n, then B will be congruent to A mod n. Transitive property. If A is congruent to B mod n and B is congruent to C mod n, then A will be congruent to C mod n. Addition and subtraction property. If A is congruent to B mod n and C is congruent to D mod n, then A plus C will be congruent to B plus D mod n. Similarly for subtraction. Multiplication property. If A is congruent to B mod n and C is congruent to D mod n, we can multiply A and C and B and D. So AC will be congruent to BD mod n. If A is congruent to B mod n and C is any positive integer, we can multiply both sides by C, then AC becomes congruent to BC mod n. Another interesting important property is that if A is congruent to B mod n, then A power k will be congruent to B power k mod n, where k is any positive integer. Applications of congruence modulo. The main application you can see in the cryptography in generation of public key and private keys. Second application is generation of pseudo-random numbers. Third one is error detection in serial number identifiers. For books we have serial number identifiers called as ISBN, and for products there will be product identification codes. If there is any error in the serial numbers of these, it can be detected using the congruence modulo. Hash function, which is used in the DBMS, is also based on the congruence modulo. Steganography also uses the congruence modulo concept. Steganography means hiding a secret message in any image is called steganography. Many other topics of modular arithmetics will be covered in the next videos. Thank you all for watching.